Hello everyone, this is Super CEO. Today is video number 4, continuing on on the development part of the section. So we're going to have a look at question 10 and 11 of the development questions we started yesterday, or video number 3. So before we formally start, so here's the waiver or disclaimer statement. Okay, so the actual questions are these two. All right, so interestingly, this time our little fx or the frequency functions in both cases are piecemeal or piecewise functions. Okay, but the way we're going to approach the question is exactly going to be the same in terms of like part A, proving that little fx is a PDF. As usual, we show that the little fx is throughout the domain is all positive, as in this case, and also show that the area of those smaller rectangle plus the bigger rectangle is 1. So that's basically what we're going to do with part A. And part B, that's depending on what x value you've got, how does the y value for the cumulative function or the CDF will vary. Now, we can expect that the way the y values are distributed is going to be like a linear fashion, because when you integrate a flat line, you get a linear function. So that's how we can guess what the values of y is going to be. And therefore, when it comes to writing down the actual expressions for the CDF, we're going to see that there will be a linear expressions. Okay, so here's the actual question. So there you go, part A. So from the given graph, we were able to see that the y values are either 0.125 or 0.25. So for the given domain, so that's ticked off. And the second condition, that's to show that the definite integral throughout the domain is 1. So between 0 and 2, it was 0.125 for the y value times the 2 plus 0.25 times 3. So that's 1. So hence it's a PDF. And part B, now to get each of these y values, you're going to have to go back to the diagram and then work out the actual area up until that x value. So let's go back to the diagram. So at x equals 0, obviously the area for any line is 0, or you could also think of it as at x equals 0, the starting point of the domain, nothing to accumulate, so it's going to be 0. So that's another way of putting it. X equals 1, so now you have developed a little rectangle. So that's going to be the area, 1 times 0.125. At x equals 2, 2 times 0.125. Remember, it's a cumulative effect, so by the time you reach x equals 3, not only that taller strip of rectangle, but also that all of those to be included, and so on. So that's the idea. So here we go. 0 and 1.125, 0.25, and x equals 3 and beyond. Notice I've circled all of these 3 common numbers because that's the actual area of the smaller rectangle, which is gotten from this. So from beyond x equals 2, you're going to have to take along these 0.125 in all of those calculations on top of the total rectangular area as you move along. So, and as expected, by the time you reach the end point of the domain, the CDF has to be 1, okay, which is the case. All right, so now part C, again, going back to part B, the table values, you just have to now plot the y values or the cumulative distribution function values against the x value. then you get this nice linear graph. And notice there's the graph starts with the lower gradient, and then beyond 2 it's a steeper gradient. Okay. All right, part D. So this is now writing down the algebraic expressions. From x equals 0 and 2, it's pretty straightforward. 0.125 t evaluated from 0 to x, which is this. Okay. Now, from beyond x equals 2, it's a little bit different. You can't just say 0.25 t evaluated from 2 to x, because that only accounts for the x values beyond 2. But remember, it's the cumulative effect, so you're going to have to write down this, which is 0.125 times 2. And where does that come from? Well, that comes from this, the tail end of the diagram, that area. So remember, beyond 2, it's the cumulative effect, so you're going to have that area no matter where your x is, as long as it's beyond 2. So that's where that number 0.125 times 2 come from. So then you get this. So that's the actual evaluation part, and that's the 0.125 times 2 part. So then if you do all that and fine-tuning your algebra, then you get this. And remember, that's only 4x between x equals 2 and 5. So that's your big fx, or CDF. And finally, actually that's it. That's the question 10. Now question 11 looks like this. Exactly the same type of question as the one above, but the only thing is it doesn't have a diagram. And as you can see, that even though it doesn't quite define what the C is going to be, from part A, for that to be a probability density function, C has to be positive, because, unless it's a positive case, then this fails to, it fails the first condition, that is the CDF, the little fx has to be positive in the domain. So we can see that C has to be positive. So that's that part. All right, so as usual, sketching it, and then part B is finding the value of C, and then find an expression for the CDF, and part D is to find the actual probability between x equals 1 and 7. Okay, so question 11. All right, rewriting this and sketching this. So like I mentioned there, he even though C is not specified, at least we can see that it's positive because of that condition. Okay, so that's why the graph looks like so. And part B, this must be true. Okay, because we know it's a PDF, so let's now evaluate this. 5C plus 5 times 2C. Okay, where do I get that from? Again, this area is 5 times C, and that area is 5, the difference between 5 and 10, and times the y value 2C. Hence this calculation, hence C has to be 1 on 15. Part C, again, the same idea that I used before. In the first part of the domain, it's just easy as Cx, okay, which is 1 on 15x. Part B, second part of the domain, it's not only this bit, but also you have to tag along the 5C. Now, where do I get the 5C from? It's this bit here, the area of the first rectangle, because it's the cumulative effect. So beyond x equals 5, see, one of the typical, if I say that's my x lying between 5 and 10, it's going to be all of this area. Okay, so no matter what, you're going to have that little area for the little rectangle to be included, and that's 5C. So that's that one, gets carried along and gives you that CDF in x equals 5 and 10. Okay, so now moving on to the last part of the question. So we now have this complete CDF, and now evaluating this, and that's just going to be big F of 7 take away big F of 1. So 7 lies in the second part of in the second domain, so you're going to have to use that fx for the evaluation, and f1 and 1 lies in the first domain, so you're going to have to use the first piece of the function. So that's that one, evaluating this. So the probability between 1 and 7 is going to be 8 on 15. All right, so that about does it for this video, and I'll see you guys next time.